Worksheet 2 covers topics of slope fields and separable differential equations and linear differential equations. The first section, section 2.1, covers slope fields. A slope field tells you what's happening to a graph over time. It tells you where the slope is 0, where the derivative is 0. It tells you where the slope is positive, and it tells you where the slope is negative. So when you're sketching a slope field, probably the most important points are the critical points. The critical points when the slope is equal to 0, and that's what we're going to look for first. Other things to consider are what happens when x is equal to 0? Is y changing at all? And what happens if y is equal to 0? Is x changing at all? Or does the slope change with x? What's happening along the axes when x is 0 and y is 0? If the right-hand side of the equation contains only the independent variable x, what can you say about the slope field? We'll come back to this in a little bit. And suppose the right-hand side of the equation only contains the dependent variable y. If it contains just the dependent variable y, then that type of equation is called autonomous. And we're going to look at the characteristics of this later on too, and then we'll come back to these questions. What happens when x goes to infinity? This is when x goes to infinity. This is on the right hand side of the graph. And then what happens as y goes to infinity? That's the upper part of the graph. Also, what happens when x goes to negative infinity at the left side of the graph, and what happens when y goes to negative infinity, the lower part of the graph. This should say, when is the derivative equal to 0? dy dx equal to 0. And how can you read that off the slope field? Well, you know when the derivative is equal to 0, the slope is 0, and the line is going to be horizontal. So on a slope field, we'll look at those in just a second also. But in a slope field, use little lines to show the flow. When the slope is 0, your lines are horizontal. If the function is increasing, then your lines are going to be going up. If the function is decreasing, then your lines are going to be going down. And a slope field could vary depending upon where you start. So both of these lines could be part of the same slope field. How about when this should be when the derivative is undefined? How about when the derivative is undefined? Well, if the derivative is undefined, then that probably means that there's a break in the graph, that you have a vertical asymptote, and you might have something on the right side going away or coming towards that slope line, or you might have something on the left side. It could be either approaching or it could be going away this from that vertical asymptote. Also look at each quadrant to see if the slope this should be, I'm sorry, my special characters didn't come up here. To see if the derivative is positive or negative. And if the derivative is positive, then you know that your function is increasing. If it's negative, you know that your function is decreasing. So let's look at some slope fields and see if we can draw them.